Hello, brilliant coders. My name is Shawn, and I will be your instructor today. You're watching the Data Science and Machine Learning series on the Coding with Shawn channel. In this video, we're going to be continuing the series with a brand new project. Now, before we do get started, I want to go ahead and get a couple of things out of the way. Firstly, the prerequisites. You need to have at least a basic knowledge of Python to understand what's going on here. If you don't have that, you can go ahead and go to my Python for Beginners series, linked in the description box below, to learn a little bit of basic Python before coming to this. You also need to have watched all the previous videos in this series. If you haven't done that, I've linked the link to that in the description box below as well. If you've done both of those things, then the last thing you need to do is download the datasets that we're going to be using today, as well as this Jupyter notebook. So please go ahead and go down to the description box below and click on the link to download the Jupyter notebook that we're going to be using today, as well as a necessary data set. If you've done that, then without further ado, let's begin. So today we're going to be starting a project called Automobile Exercise. And in this project, we're going to be learning a lot. So we're going to be learning not only basic Python, but also a lot about our libraries. Now, what we always want to understand before starting anything is what we're actually trying to do. So go ahead and open the Jupyter notebook that is linked in the description box below. Download it and go ahead and open it. So you will see this link, which says dataset to be used. So go ahead and click on this link and scroll down, and you'll see this called Automobile Dataset. So what we're going to be doing is using data from a CSV file, which has a lot of information about a couple of cars, and we're going to be doing all sorts of operations on it using Python and Pandas and NumPy, etc. So let's try to understand what this data is all about. So let's go ahead and read this dataset information. This dataset consists of three types of entities. A, the specification of an auto in terms of various characteristics. B, its assigned insurance risk rating. C, its normalized losses in use as compared to other cars. The second rating corresponds to the degree to which the auto is more risky than its price indicates. Cars are initially assigned a risk factor symbol associated with its price. Then, if it's more risky or less, then this symbol is adjusted by moving it up or down the scale. Actuarians call this process symboling. A value of +3 indicates that the auto is risky, and -3 that it is probably pretty safe. The third factor is the relative average loss payment per insured vehicle year. This value is normalized for all autos within a particular size classification, such as two-door small, station wagons, sports or specialty, etc., and represents the average loss per car per year. Note, several of the attributes in this database could be used as a class attribute. Now, if you didn't understand a lot of that, don't worry, you will very soon. But hopefully you at least understood a couple of things from there, and that is that there are a couple of different types of cars, and those different types of cars have attributes to it, like their riskiness rating, which is called symboling, and their particular size classification, etc. And you'll see a lot more about that. So if you look at what kinds of attributes there are, which it says here, then there are quite a few of them. So the attributes that are assigned to each type of car is symboling, which is what we just talked about earlier, which is about how risky the car is. Normalized losses, and you'll understand a little more about what that is soon. Make, which is basically what company made it. Fuel type, which is either going to be diesel or gas. Of course, nowadays there's also electric, but this dataset is a little old, and at the time it was made, there were no electric cars. Aspiration, which is either standard or turbo. The number of doors, 4 or 2. The body style, so if it's an SUV or a sedan or something in between. Drive wheels, which is basically how many of the wheels rotate. So 4 would mean all of them. 4 would mean just the 2 front wheels, and R would mean just the 2 back wheels. Engine location, which is basically where the engine is, the front or the back. Wheelbase, length, width, height, curb weight, engine type, number of cylinders. Some of these are a little more advanced, and you don't really need to understand what it is. You just need to understand what type of data it is. Number of cylinders, engine size, fuel system, bore, stroke, compression ratio, horsepower, peak, rotations per minute, city, miles per gallon, highway miles per gallon, and price. If you are from India or somewhere where miles aren't used, you can really think about this as miles as kilometers. Of course, there is a difference, but you can really think about it as that to make things simple. Okay, so now we've understood what kind of attributes there are, and that's going to be assigned to each different type of car. So that's really what we needed to understand right now, fundamentally. So let's go ahead and go back here. And so the problem statement, what we're trying to do by doing what the exercise that we're going to be doing for the next couple of videos is which characteristics, which one of these attributes, these many attributes that we just covered, which one of these have the most impact on the car price? So this automobile exercise is going to be a 4-step process. The first step, which we are starting today, is understanding the data. When we're understanding the data, we're going through the data, we're starting to understand what it's all about, what we're trying to do, and really finding our purpose and what we're trying to what our main goal is. Step 2 is going to be something called data wrangling. Data wrangling is, you can think about it as kind of cleansing the data. We're going to be taking out missing values, we're going to be fixing incorrect headings and columns and all of that. That's all going to be something called data wrangling. We'll talk more about that when the time comes. Step 3 is analysis itself. So we're going to be running all sorts of operations on our clean data, and we're going to be trying to learn whatever we can from it. The 4th step, which is actually surprisingly important, is turning that data from what we got from the analysis into some more visualizable ways, such as a graph, a line graph, a bar plot, and all sorts of things. For that, when we're doing step 4, we're going to especially be using Matplotlib and Seaborn. And you might think, well, is that really a necessary step? And the answer to that is a resounding yes. If we want to do data analysis, we also need to make sure that your average person, like if you're working for a company, you need to make sure that the bosses don't have to just stare at a table and try to interpret what they can. They can look at a bar graph and see, okay, this has this much effect, right? This line is more, so that means it has more effect. This line is smaller, so it has less effect. So that's actually a very, very important part. So let's go ahead and get started with what we're going to be doing today. So this first line here is just importing our 3 libraries. We talked about these earlier in this series. They are NumPy, PANDAS, and Matplotlib. NumPy is for our scientific computing, PANDAS is our data structure library, and Matplotlib is for visualization. Okay, so let's try to understand what's going on here. So initially this seems a little complicated, but if you break it down to its basic elements, it's actually very simple. So we're assigning the variable df to this. So this is just saying that we're assigning the variable df to whatever's next. Okay, so we're using pd dot. So if you ever see pd dot, then you know that's referring to pandas, because we literally wrote here import pandas as pd. So we're putting pd, and then we're using the function read csv. So dot read csv, and that's a pandas function, which is literally for reading a CSV file. So then we put the actual name of our CSV file, and you don't need to worry too much about this, but this is saying to remove all the column headings. So header equals none. Okay, so now if you run this here, if you run it, it's going to say, it's going to reject it. It's going to say, can't find the file. So what you need to do is come to your Jupyter notebook, and you need to go to scroll up, and in that link that is in the description box below, there's also a CSV file. So go ahead and download that CSV file and click upload and add it here. Once you do that, it will pop up like this. So once you click upload and you add that file, it will pop up like this, and you want to click upload. Once you do that, come back here and run this again, and it'll run perfectly fine. Okay, so then we put just df. So again, df is just our variable that we assign to this CSV file, and df is of course the data frame because we put pd.readcsv. So now when we run df, you'll notice this neat little data frame that we created using, of course, pandas, and you can start to really get the idea of what this is all about. You have all these different attributes, and it's all about the cars. Each different car has its own specifications. Okay, so our first function that we're going to be learning today after .read.csv is .head. So when we run .head, it returns the first n number of rows. Okay, so if we just run this, it's going to give us 5 rows. And the reason for that is df.head with no number put inside the parentheses is by default going to print 5 different rows. And you might say, oh, but it only goes until 4. Well, it starts at 0, and that's why. So when you do that, you'll get the first 5 rows. If we put, say, 50 here, then that's going to actually print all 50 rows from the top down. And if we put another number like 213, it's going to give us. Now, I want you to notice a couple of things here. Firstly, notice that when we did df.head 50, it actually printed all 50 rows for us. You see, it goes all the way from 0 to 49, which in total is 50 rows. But when we did 213, we got a couple of dots in between and just a few on the top and the bottom. Now, the reason for this is Pandas doesn't want to inefficiently use your memory. And so for that, if you put too many rows up where it says df.head, it's going to go ahead and cut off some from the middle. And so you do have to be conscious about how many you're actually putting here. Another thing I want you to notice is that there's only 205 rows in this whole data frame, and we put 213. So that's why I like to call Pandas a smart library, and that's that instead of throwing an error like a lot of languages would if you did something like this, it just goes ahead and prints all the rows that there are. Instead of saying, oh, you wrote 213 rows, there's only 205 as an error, it actually just goes ahead and prints whatever it has. And that's one of the neat things about Pandas. So to cover again, df.head does data from the top down. By default, it gives 5 if you don't specify anything in the parentheses. If you did something like 100, it would give you 100 rows. And of course, any number can be put there, and n is the number of rows in the data frame. Okay, so df.tail is basically the opposite of df.head. df.head returns the top n rows, whereas df.tail returns the last n rows. And just like df.head, if you don't put anything in between the parentheses, it'll by default give you 5 rows. These are the last 5, of course. Moving on, if we put 220 in there, again, notice it'll give you, that's again more than the 205 rows which there are, so it just prints all of them. And again, remember, because that number is really large and Pandas doesn't want to waste your memory for no reason, it goes ahead and just dots out the middle rows, just putting the first 5 and the last 5. Okay, so here's another function. It's called df.columns. And actually, this is not a function because it doesn't have the parentheses after it, but it's very close to one. And when you put df.columns, it prints the column labels of the data frame. So if we do that, you'll notice that it gives us 0, 1, 2, 3, 4. And that's because, actually, if you look here, the column names, there are no names. Because when we imported this CSV file, if we scroll up a little bit, when we did it, we specifically said header equals none. And the reason we did that is because the headers are all messed up in this file. So we just went ahead and put none. And so Python and Pandas make up for that by just going ahead and replacing all the columns with numbers. So going back to where we were, and you can see it printed all of them, all 25 columns, or actually 26, including the 0. Okay, df.dtypes. So this is going to be one of your most important operations, so definitely listen carefully here. Now when you run this, you'll notice that you get all of the columns, column names, and on the right side you're going to get the data type of the columns. So that's what dtypes stands for, data types. So you get the column names on the left and the type of the data in that column on the right. So you notice there's a couple of them. There's some integers, some strings, and again, object means string, int64 means integer, float64 just means float. And if you don't remember what a floating point number is, it's literally just a number that is decimal, or it really doesn't fall under the classification of an integer. If a column has mismatched data, so like if it has numbers and words and all sorts of things, then Pandas will automatically just go ahead and classify it as an object to be on the safe side. So Okay, so let's go ahead and read this. This returns a series with the data type of each column. The results index is the original data frame's columns. Columns with mixed types are stored with the object D type, as I just said. Okay, now here's a function. This is our next function, df.info. So .info prints a concise summary of a data frame. So once you run df.info, it gives you this. It first gives you the class, so this is a pandas.core.frame.dataframe. It gives you the range, so there's 205 rows. It gives you the data column, so there's 26 columns, and then it gives you a lot of helpful information. So this is actually, now notice that it gives you all the information that dtype does. It gives you the column name, and on the right side it gives you the dtype. But it also gives you the non-null count. And so the non-null count is basically, it's literally just how many there are that are not null. And null is, again, it means nothing, and that basically is what it means in pandas too. And so null basically means that there's a missing value. Now there are missing values in this data frame, but pandas doesn't know that. And we have to tell pandas that, because pandas only recognize a few different types of words. We talked about that in the last video. It only recognizes a couple of different types of words as a null. And if it's not those, then it'll just assume that it's not. And that's why it says this. But there are some values that are missing, and we'll fix that later on, you'll see. So moving on, it says, this method prints information about a data frame, including the index dtype and columns, non-null values, and memory usage, as you can see at the bottom here. Memory usage, 41.8 plus kilobytes. Okay, next thing is .index. So .index is literally just prints the row labels of the data frame. If you do that, it gives you the index, which is the start, stop, and step. So the start is 0, stop is 205, and the step is 1. So start and stop are pretty simple. Start is the first row, stop is the last one, and the step is basically just how much it's changing by. So if we look at the data frame again, scroll up a little bit, you'll see that it goes from 200 to 201 to 202 to 203, and so that has a step of 1. If it went from 200 to 202 to 204 to 206, that would be a step of 2. If it went from 200 to 204 to 208, that would be a step of 4, and so on and so forth. Okay, so now we're making a variable called headers, and inside of it, we're adding a list. So we're actually going to be we're fixing the column names here. So go ahead, and this is already here, but so we're not actually doing anything here. So notice that we're not actually running any operations here. We're just assigning this list to the variable header. So go ahead and run this. Okay, this next one is the type, and so this should be a list if we did this right, and sure enough it gives us a list. Very basic Python list here. We're not running any types of operations here. We're just making a variable and putting a list inside of it. So here's where the main things are happening. So df is our variable, which is assigned to the data frame. .columns is the operation we're running. So .columns, again, remember, just affects the columns, and we're saying equals headers. So what this is going to be doing is actually very simple. It's going to be replacing all the column names with the words in the list headers. So if you run this, it'll do nothing. But if you print df, notice, earlier in df, there were just numbers as columns. Now, though, we literally have words from this list that we just put. And that's one of the neat part about pandas. It's able to do these kinds of things very simply and easily. So moving on, if we print df.info again, now you'll notice that the column names have been updated. Everything else so far is the same, but notice the column names are now updated. Earlier they were just 0, 1, 2, 3, etc. If we do dtypes again, notice that the column names have been updated here as well. Very cool. And now we're moving on to our next function. This one is very, very, very important. df.describe, and this generates descriptive statistics. So if you run this, you'll notice that we get statistics for each different column. So we have count, mean, standard deviation, minimum, 25%, 50, 75, and maximum. So 25, 50, and 75% are just the interquartile range. And so you'll notice, now, there's one thing I want you to notice. There are not 25 columns. If you remember from earlier, sorry, the 26 columns. There were a total of 26 columns, if you notice here, and not all of them are included. And the reason is, look at some of the operations that are here. The count, now average, standard deviation, those are the kinds of things that you can only run on numbers. So the only columns that are included here are the ones that are specifically integers or floats. Because, I mean, if you had a column that had the string hello, I mean, how would you find the standard deviation of hello? What's the minimum of hello? The maximum? The average? Right? It makes no sense. So the only columns that are included are the ones that are numbers. Okay, so let's describe a little bit more. If you would like to get a statistical summary of each column, such as the count, column mean value, standard deviation, etc., we use the describe method. This method will provide various summary statistics, including NaN, or not a number values. This shows a statistical summary of all numeric typed, such as int, float, columns. For example, the attribute symboling, which is this one, has 205 counts. The mean value of this column is 0.83, as you can see here. The standard deviation is 1.25. Roughly. The minimum value is -2, as you can see. The 25th percentile is 0, as you can see. The 50th percentile is 1, exactly right. 75th percentile is 2, here. And the maximum value is 3. However, what if we would also like to check all the columns, including those that are of type object? So, as I just said earlier, the only columns that are included here are the ones that are integers or floats. But what if we also want some statistics on the ones that are objects? So to do that, we put include all inside of the parentheses. So we do this, and then inside the parentheses we put include all. Now, notice that we now have all the columns, of course, but also notice that we now have some new operations here, specifically unique, top, and frequency. So like I said earlier, you can't really find the standard deviation of the string hello, so instead we add some new operations here. So unique is the number of unique values, top is literally just what's on top, and frequency is how many times it's occurring. So now notice that there's a lot of nans, and the reason is you're not running any of the mathematical operations on the type object columns, and you're not running any of the type object operations on the math columns. So it's very interesting what's going on here, and include all means that you're running the operations on all the columns. It's fairly simple. So the next operation we're going to be running is .dropna. So .dropna, the first thing that might catch your attention there is the word drop, and that's exactly what it's doing. It's dropping something. So here we're literally removing the missing values, so we're doing it in the subset price. If we look in our data frame over here and scroll to the very right side, you'll see that there is a column called price. And so what we're doing here is we're removing all the missing values using the dropna function. Axis equals 0. We'll talk more about what axis is later, but for now, let's go ahead and put axis equals 0 and run this. Now you'll notice that all the missing values are dropped. If we look in the earlier one, you'll see a lot of question marks. If you look in the new one, there are none, and it's perfect. Okay, if we run df.head again, which is always a good idea to do after you run an operation like the one we just did, and you'll notice there are no more missing values or question marks or anything like that. Okay, so now we've run the majority of the operations that we needed to run. So now here is one of the cool parts. We're going to be using .toXL, which is another pandas function, and that does exactly what you might think it does. It writes the object to an Excel sheet. So df again is our variable that's connected to the data frame we made. If we run this, and here's where the magic happens, go back to your Jupyter notebook, scroll down a little bit, and you'll see that you now have a new file, auto1 export.xlsx. How cool is that? So whenever you do something like this, you want to go ahead and open it. So let's go ahead and file down. You don't have to do this if you don't want, but I want to do it just so I can show you how cool. How cool is this? It's now been turned into a Excel spreadsheet just like that. And this really shows what magic pandas can do. This is why people like pandas so much. You can do all these interesting things that relatively you might not really expect from a library. Like writing it to an Excel sheet, that's not something you would expect for a library like pandas to be able to do. That's something you'd expect more from, say, NumPy. But it's very, very nice that the structural capabilities of pandas here. So you run .toXL, and I think you already understand what .toJSON is going to do at this point. It's going to do exactly what .toXL did, except instead of turning it to an Excel sheet, it's going to turn it to a JSON string. So now if you look here, you'll also have JSON here. And if you look through this, you'll see now this might look a little weird for those of you who are not familiar with .json files. You don't need to worry about this. It looks really complicated, and we're not going to be using this at all. It's just to show you how this works. But it has all of the the data frame information stored in a JSON file format. How cool is that? Don't worry too much about it being confusing, because it's not actually important, but just to show you how that works. Now, of course, there are more formats that pandas can export to. So we saw we could export to CSV and JSON, but it can also do it. Sorry, we saw how we could do it to JSON and Excel, but it can also do it to CSV, to HDF, and to SQL. HDF and SQL are two that we're going to talk about a little later. HDF is something that's going to be used a lot for satellite information. We're not actually going to be using HDF much, but we might use SQL later on in this series. So it can, of course, read and save to all these formats and more. So these are the most important 5, but there's also other formats that pandas can save data frames to. After reading data into Pandas data frame, it is important for us to explore the data set. There are several ways to obtain essential insights of the data to help us better understand our data set. And those are, as we saw earlier, .dtypes, .describe, and include all, to include also the columns that are not numeric, and df.info. I always like to summarize what we did before ending, so let's talk about our key learnings today. First thing we did was read the data using the .readCSV function. The next thing we did was organize the data. For example, the headers. If you remember, we made a variable called headers and put a list with the correct column names, and then used df.columns equals headers to add that. And that changed our column names from 0, 1, 2, 3, etc. to the correct attributes. 3, we had an overview of the data using head.tail, .info, dtypes, and index, which gives us some basic details about the data. And lastly, but certainly not least, we did summary statistics for basic insights using .describe. .describe we're going to be using a lot, so make sure you have thoroughly understood what df.describe does. And with that, we pulled to a close completely. Thank you so much for watching. If you did like this video, please do consider liking and subscribing. It really helps. And if you have any questions, comments, or feedback, feel free to put that in the comments section below. Thanks again very much for watching, and I hope to see you in another video.